surface under traffic, and it actually reduces friction. It makes it too slippery. So in rainy or icy conditions, or even near ice, it's going to be dangerous to travel on. So that is false. Always a concern. We've got question 2 here. Asphalt binder content is used in volumetric determinations along with GMM and GMB. True. The volumetrics are the interaction between all of your aggregate and their properties, the asphalt and its properties, and then how we compact it in the gyratory. Question number 3. Loose HMA is placed in the blank prior to entering the ignition of it. And we have a couple different options here. Heat-resistant glass beakers, gyratory molds, metal baskets, or ceramic plates. The correct item that we're putting it in is a metal basket. Remember, they have openings on them to allow the air to pass through and around the sample because it's burning off the asphalt. Question number 4. The ignition oven uses a built-in blank to determine when the binder is removed and the burn is complete. Well, if you look through here, since we're burning off the asphalt, weight is going away from it. And really, the only thing we could truly monitor that with is a scale, D. There is a built-in thermometer, but that's not what's dictating the test. So the correct answer here is a scale, because even if it's at 1,000 degrees Fahrenheit or 538 degrees Celsius throughout the entire test, right? If we're using a thermometer, think of that. We would not know if it's complete or not by monitoring that. It should be stable. So the scale is what's monitoring the change in mass. Question number 5. Thickness measurements are made in each blank of the compacted specimen. So recall, for thickness, what we're going to do is average a certain number of readings, and that number is 4. It's approximately quarter points around that scale, or around that specimen. So B is the answer we're looking for there. Now, to make those measurements, question number 6, thickness measurements may be made using a blank: ruler, metal tape measure, or a measurement jig. And the correct answer is all of the above. So anything that is accurate to measure with is pretty much acceptable in this regard. Question number 7. One reason to ensure proper asphalt content of HMA is, and we have a couple different options here. Mixes that are too high in asphalt binder will bleed and rut. Mixes that are too high in asphalt content cannot be compacted. Mixes that are too low are impermeable. And then mixes that have the right amount of asphalt are easier to cool down. Well, B and C are actually not intuitive. Asphalt serves as a lubricating agent during compaction. So B is actually the opposite. If you have more asphalt, it's going to be easier to compact. And then C also doesn't make sense. Impermeable means that there's so little air voids or openings that water won't get through. If you have less asphalt, there's actually going to be more air voids. So these ones are definitely false. Question D says mixes that have the right amount of asphalt are easier to cool down. We're not putting in enough asphalt to impart any type of change regarding the specific heat or how much heat retention our pavement has. So the correct answer is A. And I actually already mentioned, up with the asphalt content monitoring question, is if we have too much asphalt, bleeding, flushing, and rutting are going to be concerns. With respect to rutting, the asphalt can actually pull apart the aggregate if you have too much of it. So if you think about the aggregate rubbing against each other, if you have too much asphalt, it's going to actually allow them to pass freely past each other and cause rutting very easily. So 7 is A. Question number 8. Drain down refers to, and we have 4 different options here. Water's ability to drain from a road. Well, we're talking about asphalt testing, so even if that might be, that's not what we're looking for. B, the asphalt binder draining from the mixture during silo storage and hauling. Sounds believable. Question number C, the asphalt binder draining from the mix during compaction. Or D, the rate at which HMA is loaded into the trucks at a plant. Well, the rate at which it's loaded is dictated by gravity, so that's always kind of fixed. But we're looking at the difference between B and C here. So the answer is B. It's going to be at its highest temperatures during mixing and silo storage, right? Once it's placed, we're actually already cooling down. It's in the thin mat behind the paver. So the other thing is during transport, there's vibration in the truck, and that can actually be more prone to cause drain down as well. So the correct answer is B. It's during mixing, storage, and hauling. Excuse me, had to mute the sneezes here. It is one of the worst pollen seasons we've ever had in our state. So, question number 9. Drain down is measured by holding the mixture in an oven at, and we have 4 different temperatures here. Ambient temperature, meaning room temperature, the delivery temperature, plant production temperature, or 1,000 degrees Fahrenheit. Well, if you were paying attention during the PowerPoint, 1,000 degrees is above the flash point or ignition point of binder. So we would be burning away the asphalt there. So it's not D. Ambient temperature, that's, roads are at ambient temperature. If we have concerns that asphalt is going to run away from our roads at that temperature, we have real problems. So now we're dealing with the delivery temp or plant production, B or C. This is the same as a couple questions ago. And basically, just like our question number 8, plant production temperature is hotter than the delivery temp. So that's the temperature at which is going to be more likely to be problematic. So the correct answer here is C. And finally, last question from quiz 6. Asphalt binder content, thickness, and drain down are all tests that are unnecessary if GMM and GMB are measured properly and conform to the requirements. That is false. We always have to monitor asphalt content, the thickness of our mat that's being placed, and drain down, right? They're actually separate concerns. The asphalt binder content will relate to the GMM and GMB, but you can actually get all those numbers to be somewhat similar, your bulk and your max, and have differing asphalt contents if your gradation is changing. So each one of those things has to work together to tell us the quality of the mix. So those are the questions on there. Again, if you have a concern or further questions about those, do reach out to Aaron, Jim, Scott, or I, whoever you can find. So I'm going to enable content in this PowerPoint. Today we are looking at course 7 or session 7, and we are going to be talking about paving, specifically actually constructing a road in the field. So we're going to talk a little bit about what happens before the trucks arrive. Get my laser pointer on. Before the trucks arrive, how the mix is going to be delivered, placed, and then compacted. And then a couple slides on how to construct what we call joints. Those are the physical separation between different pulls or mats of hot material placed. And then finally, things to look for with respect to quality and accepting and what happens when we have differing opinions on the test results, especially between a contractor and an agency, right? The person being paid to do the work, or not person, but entity being paid to do the work, and the entity who is paying the work, cutting the check. So before we pave, we need to have proper preparation. If you go out to pave and you have puddles and trash and soft material that you're expected to be paving on, whether you're working for the contractor or an agency, it is your duty to say, hey, we're not going to get density on this. It needs to be smooth, clean, uniform, and ready to be paved upon. So we're looking for homogeneous, which is meaning that it's going to be uniform, right? This picture here, we're looking at a milled surface, and you can tell it looks pretty darn uniform and pretty clean. The dirtier it is, the more that dust is going to sop up our tack coat and make these layers not stick together, right? If you've ever handled dough in a kitchen, for example, you put flour on your hands and on the surface you're working on so that dough doesn't stick. We want our dough to stick here. So we need to have no small particles keeping that tack coat from sticking the two layers together. It also needs to be sturdy. If it's not strong enough, we can't expect to push on it with a roller, right? What's actually going to deflect is our entire ground beneath our new layer, not the layer itself. And then finally, addressing cracks. Cracks are really important. I realize it's the third and not the fourth bullet, but I wanted to talk about that last. Addressing cracks is really important because a crack is an indicator that there's movement in that area. Movement in engineering terms is strain, but whether you call it movement or strain, it doesn't really matter. The more that the pavement structure itself is moving under loads, the sooner we're going to see cracks in our new layer. That's called reflective cracking. So here we've got a couple pictures of, this is a road. I was actually on site during paving, and you can see up in the top here, there's a tack truck placing tack coat right next to debris. they actually didn't even take the time to sweep away or shovel away this type of material here. So you can probably guess how the finished product is going to turn out, right? This is the same road. This was all one project. Right here, we've got failure to prep a pothole essentially, right? There's raveling or some sort of settlement that happened here. So there should have been patching that took place or crack sealing in some of these other locations. The reason this is such a concern is even if you pave over this with a paver and make it smooth and black on day one, there's going to be stress concentrations, meaning as a truck goes over this portion of the road, it's going to hurt the road more in the shallowest parts, and there'll be this big transition there and quickly create cracks in the surface. So the other important thing to note here is this isn't necessarily the contractor's fault. They might have been told, just pave it. We know it looks bad, just pave it, right? And to that end, it might not be the municipality's fault in a sense if they're the ones who prescribe that. Sometimes people do put what's called a stopgap measure, basically a band-aid over a road, realizing it might only last 5 years or 3 years. So there are certain situations where you just do this quick and dirty type of repair. And actually looking at a road like this, it's probably in line for a full reconstruction. But we were there and we observed paving. And, even if this is a stopgap measure, they could have swept along this to take those loose chunks out, right? This chunk here is not going to do any good. So it needs to be prepped, it needs to be cleaned, and it's pretty intuitive. If you look at a road and it looks like this, you that's not going to be as good of a finished product as this, right? And unfortunately, it does come down to oftentimes this picture is an airport, so there's a lot more money being spent on preparation. This is a municipal project and they have very constrained budgets. So there's always this trade-off. And that is the case with paving. We're often never satisfied with the products we place because it's some sort of settling. We're always settling for not the best thing, right? The best thing would be to absolutely reconstruct this road all the way down to its depths, but we don't have the budget for that. So we're going to do the cheapest thing to help hold it over in the meantime. So we want to clean the surface. That's often done with street sweepers, leaf blowers, power brooms, even a manual broom if nothing can be done. Honestly, if you've milled a road, just leaving it open to traffic for a period of time can serve as cleaning. That and rain can help rinse away dust. So the next thing we're going to do is check our equipment. And one of the questions we want to ask is, can we use and are we using a material transfer vehicle? That's what this is here. I liken it to a giant brontosaurus. You've probably seen these on a construction site. They are massive. And the reason is, like this particular model, the Road Tech, it can hold an entire truck or more, up to 35 tons of material inside it. So what we're doing here is we're separating the delivery of the material from a truck coming from a plant over here from the paver. And you can see in the paver, we've actually got this hopper. So previously, before this technology existed, all trucks dumped their material directly into the paver. And this is a problem because it created what's called contact paving, where the paver had to hit the truck or the truck accidentally hit the paver, bumping the screed and creating bumps. It also helps to remix the material and create a homogeneous or uniform temperature in our mat, which is going to make the density better in the long run. The one concern with using material transfer vehicles is because they're so large, you might have exceptions to using them near bridges that are restricted to certain loads. So that's the first thing you want to look at. The next thing you want to make sure you have on site is a tack truck. Tack coat is that thin asphalt and water mixed together. And the idea is we've blended small particles of asphalt in water to make as thin an application as possible. Asphalt is sticky like molasses, right? And if you imagine taking molasses with a paintbrush and trying to paint anything like a car or a wall with it, it's going to look terrible. It's going to be non-uniform and thick. And we don't want that. We want it to be a consistent thickness. So we use this watered down version of asphalt called an emulsion. We're going to spray it out the back of this truck. And it is at an elevated temperature, but because there's water there, it's not above boiling point. So we're talking about 120 to 150 degrees Fahrenheit. It gets sprayed out. You can see the steam because it is hot. And then we have to wait for that water to evaporate. It's called breaking. This is really important though. This is the glue between our layers. If we don't have this, the layers are going to move independently and we're going to have more movement, more strain, and faster cracking. This is what creates top-down cracking in our roads. Um, it's also going to help prevent water migration between layers, but it does not reduce the need for clean surfaces. And that's what I was mentioning with the dough, right? If you want the dough to not stick, if you're making pizza dough or bread, you put flour on it. The dust in our road is that flour. And in our cases, we want it to stick, so we don't want the dust. So similar concept, but opposites. Important to realize that. It needs to be uniformly distributed. So these nozzles here, you can see are triangular shaped spraying out. If they're dirty, they end up trickling like a hose that's left on. We want it to be consistent amount of tack all across the mat. You need to wait for it to break. So it has to be, it turns from a dull brown when it's fresh to a glossy black once the water has evaporated. That's a really important difference. If it's dullish brown, it's still fresh tack. Once it is broken, it becomes glossy black like asphalt. And we want to ensure we have the proper coverage. And actually, inspectors, when you're paving on a state project, for example, are going to calculate how much was put down. It's called a tack coat application rate to make sure that they got enough there. This is also a similar concept to laminated boards. If anyone's ever constructed things with wood, plywood is an example of a laminated board where you've got thin layers of wood glued together, and the glue gives it its strength. You might also actually do this with multiple dimensional lumber, like 2x4s can be glued and nailed together to give additional strength of just one or two that aren't glued. The glue has an important role. And if you don't believe me, I don't think I have a ruler here. But if you had rulers or popsicle sticks, you can try this experiment where you take 2 or 3 popsicle sticks and try and flex them when you have them, hold them in your hands unglued, then glue them with just Elmer's glue, let them dry, and try flexing the same 3 popsicle sticks again. I guarantee the ones with the glue will be stiffer. And it just has to do with it's not necessarily the glue that's increasing the stiffness, but the fact that the glue is holding them together, it gives them a lot more strength. So tack coat, when it's applied in the rain or applied too thickly, is going to have the same effect as pushing our layers apart. This same phenomenon will exist if we have dirty interlayers, right? So if we have dirt and dust there and we apply tack coat, even if it's the perfect rate, we're going to get this condition known as slippage. And that's when the surface layer just slides along under traffic loads. So the loads are going to arrive on site in haul trucks. They're typically what we call triaxle trucks, which have the 3 rear axles. That's how you know it's a triaxle. But it can be an articulated truck. It can be a smaller truck. But the important thing about triaxles, and that's by and large what you see on our haul sites, they hold about 20 tons. They're often restricted by the roads they're traveling on. They can hold more than 20 tons physically, but probably sometimes as little as 18 tons or less. It really depends on if they're on municipal roads with bridges with weight restrictions, that sort of thing. We're going to have someone standing by either our material transfer vehicle or paver hopper, and they are going to be our spotter, making sure the trucks can safely back in to discharge their loads. They coordinate catching the truck with that hopper. They're going to check the temperature, and they're going to collect a ticket, a delivery ticket from that truck. So every truck that leaves a plant has a ticket with them. And that ticket tells you what the project is it should be going to, the time and day the material was loaded. It's going to tell a whole host of things. And I have an example ticket coming up. So right down here, I've quoted the state specifications. This is the Connecticut DOT Form 818, Section 406. You definitely don't need to memorize that, but that is the state contract language on how material is paid for when they're doing paving projects. And it says, any material that falls outside the specified temperature range as measured by 2 of 3 thermometers may be rejected, right? If we don't want it, if it's too hot, we don't want it if it's too cold. We're Goldilocks. It needs to be just right when it arrives on site. And there's reasons for that. We're not settling here because the state is trying to pay the prescribed price for the product that they're getting. So with respect to that, if it's too hot, We've oxidized our binder. Remember, we've talked about that with respect to the liquid asphalt. We also might have burned off any polymer if there was polymer modification. If it's too cold, we can't expect to get the right amount of compaction once it's gone through the paver. So to that end, we're really shooting ourselves in the foot or selling ourselves short when it comes to material that's too hot or too cold. So this is actually the point where we check the temperature and we're going to actually accept the material and let it fall into our hopper at this point. If you're paving on a street where you've got overhead wires, you can see in this picture, right? This is actually really challenging and something the paver operator and the truck operators are pretty well tuned in on, because you can see that's going to make for a shutdown of the job site. If that truck rips those wires off the telephone pole, everyone's going to need to steer clear until the utility company can come secure the site. So something to be very attentive to, especially in urban settings, but even on highways, you'll actually see when a construction site gets set up, you might have wondered about this in the past. There'll be traffic cones and actually some high visibility orange that's dragged across low wires on highways to help alert trucks, especially at night, right? We're doing most of that paving at night. So here's an example of a delivery ticket. And I'm the person who actually took this ticket. Checked by me back in, let's see, when was this? 2014. Oh my God, 10 years ago. That's insane. All right. So this was a project I was actually on. And there's a whole host of information. And every ticket from every plant, right, it comes down to what the plant's software is. But every ticket looks slightly different, but they're going to tell you roughly the same information. So here we've got the date and time, right? June 16th, 2014. Hopefully you were at least born by then. I don't know. Eventually I'm going to show this picture and people, that'll be before they were born. Anyway, I'm sure you are all probably alive at that point. It tells you the project. This was up in New Hampshire. It's an FAA P401. That's the name of the mix. And then we've got other information here. So total tonnage, gross tonnage, 70,407 pounds, which is 35 tons. We also have project tonnage too for the day. So we have 2,407 tons and loads to date, 632. So there's a whole bunch of information on here. Most plants, most modern plants, this one was an old plant. It's going to tell you a little bit more about the batch as well, like what type of stone and what type of asphalt binder went into it as well. So it's time to play everyone's favorite game. Oh no, I muted the slide, sorry. It said name that part. But anyway, we're going to go over the parts of the paver. You're probably like, this guy's crazy. And I am, but yeah, it's Friday morning. So this is a picture of a pretty modern paver here. And we're going to go over some of the parts. The first one is the hopper. This is where material enters the paver from a haul unit, or you have an insert for an MTV. But the idea is it's built to receive material. There's actually slat conveyors down in the bottom that are going to drag material back through the paver. Slats or rakes, those are the conveyors. In the back, we've got our screed. This is the most important part of the paver, in my opinion. It is what's going to smooth it out and give it a uniform surface out behind the paver. In front of the screed are augers, and these are kind of what they sound like. It is a screw-shaped thing, but it's laying on its side. And the reason we have this here is it takes the material from the hopper, brings it to the back, and transports it out laterally in front of the screed. If you imagine, I don't know if anyone's ever pushed snow with a shovel, even by hand. If you push a lot of it, it turns into a triangular shape, right? It's not evenly distributing off the side if it's kind of sticky snow. The same thing will happen with our sticky asphalt, right? We need something to mechanically transport it out to the full width of our paving. We've got a joint matcher on this one. So the point of this is we have technology that's actually going to help adjust the height of the screed as we're paving. This one's going to be matching an adjacent lane, but there's also something called reference beams. I don't know if we'll see a picture later on that are actually going to average out the slope of the ground underneath the paver and give it a smoother transition. Here we have a flow sensor. So all the way at the end of our screed, right, width-wise, we have a sensor that tells the computer in this paver, hey, I need more material. So it's going to speed up the slats. It's going to speed up the augers, and it's a closed loop Wow, closed loop
Hold
system.
on.
So that's giving the feedback to the paver, telling it, based on the speed it's traveling, do we have enough material coming all the way out? So that is the paver. I'm just gonna mute you quick here, Yusha. Not sure if you're aware that you are unmuted, but anyway, now you are. So that's the paver. It's the moneymaker, right? Without the paver, we really aren't going to be placing material in a uniform way. And what we're looking at here is a crew placing an original lane, right? So you can actually see the joint being constructed here with the mobile reference beam. So this is perfect. This is the other type of technology you would see on a paver. And what's happening here is you may, if you've watched a construction crew long enough or seen pictures or videos, you may have seen in the olden days, you'll still see it to this day when they're not using technology, but there'll be people on the back of the screed making adjustments to these cranks. What they're doing is they're manually raising and lowering the screed from its toe point, which is all the way at the center of the paver. So I thought I had an arrow that showed it, but and it's a little hard to see because it's black, but the screed is only connected to the paver right down here at the toe point. There's this long, heavy duty arm on both sides that goes back to that. And the reason being is as the paver rocks or pitches over non-uniformities on the underlying ground, the ground it's traveling on, we want the screed to be a little immune to that, which is a good thing. So the material gets extruded from the back. The vibrator on the screed helps give it some initial compaction. There's also a heater on the screed so the material doesn't stick. There's a lot happening on the back here, and you can actually see there's computer controls. There's a whole host of things happening right on the screed. And it does honestly feel a bit like a party, right? There's people hopping on and off. The paver's tooting right along at a steady clip. The paver itself is a pretty cool piece of technology, right? There's a steering wheel and controls for the operator on either side so they can get a good view of what they're doing. Because you can see for this operator, there's a lot of things blocking straight ahead view. So it's really important that they can see out the side of the machine. The other thing worth noting here is we've got a notched wedge joint being constructed. So we're going to talk about that in a couple slides as well, but really important to note that. And the mobile reference beam, as well as the toe point, we can be adjusting the thickness of our mat with those. So the same paver can pave 5/8 of an inch thick. It can pave 8 inches thick. It depends what you set your screed at. But the other important thing to note there is you need material being delivered fast enough to meet whatever thickness you're paving. And there are going to be challenges with thinner and thicker paving as well. By and large, when we're paving dense graded hot mix asphalt, super pave asphalt, it's going to be between 1.5 to 2.5 inches thick per lift. When we get thicker, we're talking about base lifts with thicker aggregate. And if we're paving thinner than that, it's probably going to be some sort of specialty mix. Here's a great picture of a wing of a screed. So we've got tunnel walls here that can actually extend out as well. Inside here, you've got the auger. And in this picture, the auger is actually overfilled. You should be able to see the auger. We'll see another picture in a second where you can. Now, the reason this is a problem, if there's too much or too little material here, the auger is going to cause segregation. And if you remember, that's when the large particles and the small particles move differently, just like your cornflakes or your bag of potato chips, right? You can think of segregation, and this happens with rocks as it would with potato chips. The large particles stay on the top, the smaller particles will trickle down, right? When you get to the end of your bag of chips, what's left? It's only the small stuff. And you can actually see that to some degree here. There's large stone making its way down to the bottom, and you can see this big layer of fines right here. The gradation is going to be different. That means the density is going to be different out the back of this paper. So the good way is right here, and you can see the augers, and this actually is a video. So let me shut off my laser pointer. You don't need to hear that noise. Imagine loud engine noise all day long. That's what paving is on site. But the idea here is the paver, the slat conveyors, and the auger should all just be going a constant, slow churning speed. I say when anyone, if I'm ever being an inspector, acting as an inspector, and I'm on site, when I see people running around, That's a bad sign. It doesn't mean they're working hard. It means they weren't prepared. I honestly like to see people leaning on their tools because it means everything is working right. And the same goes for the paver. If the paver has to move fast or the auger has to be moving fast to transport material out, that means something wasn't set up right. So this slow churn that you see here, excellent. This is perfect. And you can see the material moving continually down the auger. Here we've got the mobile reference beam in front of us. So that's monitoring the height of the ground beneath the paving operation. And there's tons of wires associated with all the technology on. Modern pavers are pretty cool machines. I've never had the pleasure of driving one myself, but they're fun to be around. There's a lot going on there. Some additional features that I've already mentioned are screed heaters. So that helps keep the material from sticking. So if you've ever encountered a situation, or I'm sure you haven't yet, but when you're on site, if you notice tears in your mat, one symptom might be that the heater is not working right in your screed. And there should be ways to monitor that as well. There's also going to be the vibrator that gives the initial compaction, and you should be getting close to 80% compaction out the back of the screed. Finally, there's also ventilation. And you could see this better if I jump back to this picture here. This is actually a big vent. So it's going to be drawing in any smoke coming off of the hottest material here as it's being delivered from a truck. And it's going to help make it a more pleasant experience for us working around this paver all day long. And you can see here's some interfaces from pavers, right? Pretty advanced tech here. It's not just levers and knobs anymore. There's computer interfaces that people are going to be expected to work with. And there's a lot of controls here. So much of these arrows pertain to the screed brake and the crown. And what I mean by that is when we build a road, we're going to put some sort of slope on it. It's actually weird to think about, but if you're ever walking on the road you live on, if you don't have a sidewalk next to it, you're always walking at a slight slope. And the reason being is we don't build our roads flat because that makes them prone to drainage. In fact, it's usually going to have as little as a quarter or 0.5% slope. In that low range, you're likely to start seeing ponding. So it's preferred to have 1 to 3% for a cross slope. We call the highest point in any road the crown, and then whatever rate at which the road falls from there, we call the cross slope. But a paver can build a road in this manner, whether it's flat underneath or not. The screed can actually be rocked one way or another, and you can actually break it in half. And it won't be irreparable. It's made to do this. A little hard to see in this picture, but the screed basically half can go one way and half can go another way. So you can build smaller crowns. Now, once it's come out the back of a screed, we are ready to compact it. When we're talking about compacting it, we are talking about what people, lay terms, would call a steam roller. We call them rollers or vibratory rollers. There are different types of rollers. So there are actually kind of four main types. There's a static steel wheel, a vibratory, a rubber tired roller, which you don't see too often in our state in Connecticut. Although if you go to a state like Maine, you'll always see a rubber tire roller. So it really comes down to the preferences of contractors. And then finally, an oscillatory roller. But besides the types of rollers, there's also three main zones of compaction. The first one closest to the paving operation, we call this the breakdown position. And it's going to be the hottest. It's usually between 275 and 250 degrees Fahrenheit. Now, this is where most of our compaction takes place. It's also going to be the slowest moving position in your paving train. So it's really interesting is if you're ever figuring out how much you can pave on a given day, and you'll probably encounter this type of math later on if you stick it out in the paving industry. The breakdown roller is technically your critical path position. This is the slowest moving item in your paving train. After that, you might see an intermediate roller. This is definitely going to be the case on larger projects and state projects, but if you're paving on a town road, for example, you might not have this operation. You might only have two rollers. And then finally, you've got your finishing roller. And this is the lowest temperature position. It's also the one where we're basically just helping with aesthetics, taking out any grooves or drags that might have been put in place by the rollers. Now, the first roller is the most basic kind, static steel wheel. What's happening here is we have the weight of the roller and we have a heavy duty steel wheel drum that's just going to roll over our mat and compact it and smooth it out. Now, the drums, whether it's on a steel drummed vibratory or oscillatory roller, all have scrapers on them to make sure material doesn't get picked up, as well as nozzles that are going to be continually spraying water on them. And that is where the steam came about in the steamroller, I think. Although the original ones were steam powered. So I don't know, like a steam engine, right? It's not clear to me whether the term steamroller came about because they make steam or because they were steam powered originally. But you don't need to call it a steamroller anymore. Anyway, it sounds funny. Uh, so yeah, there's a little bit of water being sprayed on these wheels to help keep the material from sticking. If material sticks on a drum, the roller operators are tuned into that and they will be stopping quickly because it's going to get bigger and bigger like a snowball and quickly cause big problems in the mat. The diameter of the drum, as well as how deep it settles into the pavement, is going to affect how hard it's pushing, and it's often used in the finish roller zone. Now, the vibratory roller is going to look essentially the same, but it's using eccentric weights or non-symmetrical. So they're spinning around the roller drum, but they're offset. So the idea behind this is, and I don't know if you've ever done this or you can think about it, but if you put a ball, a heavier ball in a bag, like a bowling ball or even like a solid rubber lacrosse ball would be a good example, and you spin it around, you're going to feel it pulling you up, pulling you down as you get that ball spinning. And that's what the eccentric weight is doing inside this drum. And it's actually picking up the drum and dropping it. It's making it jump on the pavement. And you can imagine that doing this imparts greater compactive effort. It's going to be pushing more down on our pavements. There are some challenges with this, though. If you're vibrating too much, you can cause the material to move. If you're not vibrating fast enough, you create a condition known as washboarding, where as a car drives over it, it's going to make a noise on the tires, and it's actually going to degrade the pavement faster. If you look up I-95 singing pavement, we actually had a road built in our state a couple of years ago where someone was going too fast with a roller. And now on I-95 near Mystic, if you're going northbound, I believe, close to the New York, Rhode Island border, you'll hear your tires start to hum. So not ideal, right? We don't want that to be the case. And then we most likely are going to be using these rollers in the breakdown position when they're vibrating. And we don't use vibration in the finish position because they're actually making marks in the pavement. So it would not be a good finished product. The rollers are going to come to a start as they change direction. Sorry, what I'm trying to say is, as they're changing direction, they also are going to be turning their vibes on and off. And the reason being is if they come to a stop with their vibration on, they're going to mush the pavement and cause it to slide. So you'll notice that they stop as they change direction. Here's a quick video again of a vibratory roller going by. And what's really cool is if you look quickly there, because of the water, you can actually see the impacts happening. Whoops, I want to show that video again. Can't do it. So you can actually see the lines. Those are the impacts. And if you were to take a picture of that after marking about a foot out, you can find the ideal spacing, which is 10 to 12 impacts per foot. The other important thing about vibration is it should not happen on bridges, or if you know you have shallow or old utilities nearby, these can break them. It's really important not to vibrate on a bridge. And if you're near like a clay pipe, an old clay pipe, you're likely to break that as well. Um, it's pretty loud when the vibes are turned on. You will feel it in the ground nearby. Very, very forceful. It's good, right? We're trying to get density. We want that to happen. So a more modern version of this is called an oscillatory roller. And what happens here is the drums actually vibrate side to side instead of up and down. So they give a real good kneading effect to the material, but it's also less destructive. So you can actually oscillate on a bridge. It's less likely to break utilities. And the interesting thing about oscillation versus vibration is you can tell a difference. Vibration sounds like you're hitting something, whereas oscillation sounds like you're kind of slapping it. Very different sound. And most of the time, oscillatory rollers are going to be orange just because Hom, the manufacturer, was one of the first ones to put that technology out. You can get other types of oscillatory rollers now too, so that's less and less likely the case. Another interesting thing about oscillation is you can run your oscillatory uh, machine mechanism in the final position, in the finishing roller position, and you would uh, be likely to still get some compactive benefit to that, right? It's not going to continue to change the shape of the surface like a vibratory roller would. Now, the thickness of the lift, I mentioned our screed is what's dictating this, right, out in the back of the paver. The lift thickness is going to be dictated by the design of the road, but also the type of aggregate we're using. So it needs to be at least thick enough for the aggregate to pass over itself while it's coming out the back. That makes sense, right? If you are paving it too thin and you get two large stones that hit up against each other as they pass under the screed, it's going to cause tears like this. What happened here was they were paving too thin. And you can see that surface looks terrible. It's low density. It's going to be prone to moisture and oxidation, and it's going to ravel prematurely. Like in 3 to 5 years, that will be like impassable. It needs to be patched. Thinner lifts get more difficult to compact. They also are harder to place. They're going to cool really quickly. So the thicker the lift, the easier it's going to be to construct, essentially. But we're not always the ones picking our lift thickness. That might be dictated by design. Now, we've talked a lot about segregation over the period of these courses, over the course of these periods. No, that doesn't make sense. And what we're talking about here is segregation. In this case, that's happening during delivery and placement. So this first one over on the left is known as truck end segregation. And what's happening is as the material flows out of the bed of the truck, the larger stones are going to make their way into the paver first. They're going to make their way through the conveyors first, through the augers first, and behind the screed first. So you actually see this manifest as chevrons. And if you're ever really bored, go look at a road. If you happen to know if it was constructed without a material transfer vehicle, you'll be able to visually discern each time a truck change happened just from this segregation. Now, centerline segregation has actually been on the rise lately in our state, I would say. And you'll see this happen because of paving too thin, or if the paver itself has improper equipment that's going to be pushing the material under the gearbox for the auger. You're going to get some type of segregation and low density there. And that ends up being a problem because you get a crack down the middle of your road, right? As soon as there's a crack, it's more water and more oxidation, and the road degrades faster and faster. Now, this joint edge segregation is going to occur when you don't have the proper setup on your paver with the wings of the screed. So if they're extended without the auger also getting an extension, you're likely to be casting large stones out and you're going to be getting segregation there. Anytime you get segregation, you're getting differential compaction. So this is going to be low density compared to the blue parts. Again, out here, the green is going to be low density compared to the blue parts. Now, truck end segregation here, this is something like one single operator has a problem with the way they're getting in and out of the hopper, and you're going to get this periodic segregation as they're being loaded improperly. And then there's finally random segregation, which could be spillage from a truck or that sort of thing. Handwork around utilities is likely to cause particle segregation as well. Now, with segregation, besides particles moving away from each other, there's also a concern called thermal segregation. And all this means is different temperatures exist in our construction. If we have different temperatures, think about this. The colder one is going to hold the roller up as it's trying to compact over the warmer parts. So in this picture here, even though this is warm, the roller is going to essentially bridge it by riding on these two cold spots. And all of it is going to be low density. So it's really important that we have a uniform temperature, not just hot in certain areas, but it needs to be consistent across our mat. This is what we're looking at here is a picture of a mat behind a paver using a thermal imaging camera. You can actually pick these up if you have a lot of money to waste. There's a lot of cool things that people do with thermal imaging cameras, not just in the paving realm, but they're a pretty cool tool. Thermal segregation, just like particle segregation, decreases the life of the pavement, and you're going to see higher air voids in there. Also, whenever you see particle segregation, you are also going to have thermal segregation. So there are other ways we're going to cause problems with segregation in our mix. The first one is with folding the hopper. So in the case of not using a material transfer vehicle, when you've got the hopper on the paver receiving material from a truck, it can fold its wings in to help that material make its way into the slats. And in and of itself, this isn't a bad thing, but it has to be done after every single load. And you can see why that becomes a problem. If the paver operator is distracted and only doing this periodically, there's going to be cool spots forming on the outsides of those wings. And then basically as it folds it, cold chunks of material will be sloughed into our mat and create these cold spots. So the best practice here is to do it after every single load or just skip it. And honestly, what's easier? Remembering to do something every 3 minutes or not doing it at all? I would choose not doing it at all. So that's a source of problems with segregation. Another one is at the joint, longitudinal joint construction. Now, what we see here is someone doing a very bad thing, and this is called creating a common elevation between the new joint being constructed and the one we're paving against. You might also hear this new mat being referred to as an infill lane. But what's happening is we want a certain amount of material at that joint so we have the correct amount of density. And then this laborer is actually pushing it away onto the mat because they think that, oh, there's going to be a lip here. Now, when I go out onto a site and I look and I can't see a joint, I know that that material has been cast away and there's actually going to be low density there. You want to see a little bit of a lip after construction. That's the sign that they had enough material here. And unfortunately, it's not this person's fault, right? They're working, they're putting in their effort. They just don't have the right information. So it's up to someone who's like a quality control person, right, to come up or an acceptance inspector and say, hey, I appreciate the effort, but you are being a little too aggressive with that hand tool. It's called a lute, this machine. It looks like a rake, but its term is a lute. Let me show you how to properly bump this joint. And I think we have a picture of a bumped joint instead of one broadcasting here. You can also see, besides the fact that all that material is being pushed away, he's creating segregation, right? There's large stones being cast out onto the mat. And you will actually see shadowing on roads as well when this has been done. Broadcasting material, bad times. So these longitudinal joints have to be built because we don't shut down a whole road when we pave it, right? We leave one lane open so traffic can come, right? Stop. One-way traffic can occur and we don't totally disrupt people's lives. But because of that, we're going to have to build a joint down the middle of our roads. Now, poor joints can occur when the material is not not receive the right amount of density, low density, right? Water is going to get in, it's going to oxidize faster and fail faster. That is going to cause it to open up. And you will see when a low joint density occurs, a mat will look fine, and then you've got this big crack going down the road. A good example of this right now, if anyone lives in the area, I-84 westbound in Vernon, Manchester, there's some pretty severe longitudinal joints opening up. I think it's going to be repaired this year. They've been working back towards that area for a handful of years, but right now those joints are in pretty rough shape. The goal is to minimize handwork at the joint, right? If everyone's leaning on their tools, they're either not paying any attention or everything is going right. And I'm hoping everything's going right. But if the paver is set up such that someone is always needing to touch it with a hand tool, it is not set up right. The paver should be able to do everything we need without needing to be touched by hand after the fact. So unfortunately, and it's kind of an education effort to the paving crew. They're kind of like the pilots in an airplane, right? Most of the time, autopilot is doing its thing, and they're just there in case something goes wrong. The same is the case for the crew behind the paver. As long as the paver's set up right, they shouldn't have to touch the mat regularly. So we construct in our state primarily notched wedge joints. And what this is, oh wow, I have a lot of slides left. Well, you're getting a thorough education on this. So it's 10:55, which I suspect a lot of you have to get to class pretty soon. So I am going to stop at this point and go over some logistics. There is a quiz 7 posted, but the fact that we haven't made it through this PowerPoint, we'll wrap it up next week. The fact that we haven't finished it means you may not be able to answer all the questions. So have a look at it to see if you can answer as many as you can, and then we'll definitely go over the remainder of this chapter next week. But at that point, I'll come to a stop here, and if anyone who's on has specific questions, certainly let us know. Otherwise, have a good weekend and good luck getting to your classes.